Hi, this is our video for Mat183 Calculus 1, Application of Differentiation. And the topic that we choose is Applied Maximum and Minimum Problem. Our group members consist of me, which is Alif Izzuddin bin Remy. Other than that, it's Muhammad Farhan bin Zulkifli. And lastly, Christopherson Bunsu and Ali. We on to acknowledgement. We're really grateful because we managed to complete this video presentation within the time given by our lecturer, Dr. Siu Chin Ying. This assignment is impossible to be done without amazing cooperation and effort of our group members, which is me, Farhan, and Chris. We also sincerely thanks our lecturer for Calculus 1, Dr. Siu Chin Ying, for the guidance to help us by teaching this course. Last but not least, we would like to express our gratitude to our family members who keep encouraging us all this time. Introduction. In Sir Isaac Newton's day, navigation was one of the biggest problems at the sea during sailing. At some point, calculus existed and has improved the navigations drastically. As a result, reliance on stars for navigations is getting lower among peoples. Furthermore, shipwrecks usually occurs because of the captain, in which have a lack of knowledge of how the earth, stars, and planets move with respect to each other. But with the help of calculus, it can now solve this problem in many types of real-world problems. Differentiation can be applied by calculating the maximum and minimum of particular function, but it can also be used in our daily life like maximize a profit in the company, to minimize costs of our business, or to find the least amount of material to make a particular object. Our problem statement. A rectangular fish pond with an area of 60 meter square is surrounded by a flower border with 3 meter wide on two sides and 2 meter wide on the other sides, as shown in figure 1.0. Let x and y be the length and width of the fish pond respectively. Question A. Show the combined area A equals to 4x plus 360 over x plus 84. Question B. What dimensions of the fish ponds will minimize the combined area? Question C. What is the minimum value of the combined area? These are the figure of 1.0 as mentioned in the problem statement. The objectives for this problem statement is to find the combined area formula in terms of x. Other than that, we also need to find the value of x and y by using differentiation method. Lastly, we need to find the minimum value of the combined area. Question A. We analyze the question and identify any useful information and then use it to get the area formula of flower border. By finding the flower border, we automatically will include the area of fish pond. So this means that the area of flower border equals to the area of combined area, which is flower border and the fish pond. From the question, we know that the area of fish pond is 60 meters square, and the formula for this area of fish pond is x multiplied by y. You should get x, y. If you combine this information, you can get 60 equals to xy. To make our job easier later, we express y in terms of x, and then you should get y equals to 60 over x. In order to prove the question that we get the exact same equation, we must first find the flower border width and the length. From the equation of the figure 1.0, you can see that the width is 2 and the other side is 2. In order to get the full width of the flower border, you must add all of it, which is 2 plus 2 plus y equals to 4 plus y. Same for the length. It has 3 on the other sides and 3 on the other sides. And the length of the fish pond. In order to get the full length of the flower border, you must add all of them, and then you should get 6 plus x. In order to get the equation of the area of flower border, you must multiply 4 plus y with 6 plus x. If we multiply it properly, we should get 4x plus 360 over x plus 84. But in the question, before we recklessly solve our equation, we must be cautious because in the question, the equation doesn't have any y. So we must substitute y from the information that we get earlier. And the answer we should get a equals to 4x plus 360 over x plus 84. Question B. As we soon as we soon as soon as we solve question A, we use the area of our border to formula to differentiate, and then we equal 0 the equation in order to get the value of x. After that, we must differentiate the equation for the second time to confirm that the value of x is minimum. From the question A, the equation is a equals 4x plus 360 over x plus 84. We differentiate it with respect of x. We should get 4 minus 360 over x squared. After that, we equal 0 the equation. So 0 equals to 4 minus 360 over x squared. From this, we can now solve the equation and get the value of x, which is 9.487 meters. To prove the value that we get is minimum or maximum value, we must differentiate the equation for the second time. After we differentiate it for the second time, we should get 720 over x cubed. After that, we substitute the value of x into the second differentiation of the equation. After that, we should get the value of 0.843. And this value is more than 0. So it is proven that the value of x, which is 9.487, is a minimum value. After we get after we proven the minimum value of x, we should also find the minimum value of y, which is 6.324 meters. Question C. After we solve question B, we've obtained the minimum value for x. So use the value and substitute it in the area of flower border formula to get the minimum value of the flower border. We use the same equation from the question A, which is a equals to 4x plus 260 over x plus 84. And then we use the minimum value of x, which is 9.487. And then we substitute x with this value, and then we should get 149.895 meters squared. So the minimum value of the flower border is 159.9 meters squared. Conclusion. To find a maximum or minimum value, you must apply or use a mathematical method, mainly the application of differentiation. These are the steps that we must follow. Firstly, find the derivative. Secondly, equal the derivative to 0 and find the value of the variable. Lastly, do a test on the second derivative. If the value of the second derivative is less than 0, then it's a maximum value. And if the value of the second derivative is more than 0, then it's a minimum value. That's all from me.